Good evening. In the last lecture, we discussed about factorial notation. We will not be solving all the sums from 5th, 6th, 7th, 8th, 9th, 10th. I'll let you know. We will be solving 5th sub question from question number 5. Prove that n plus 3, in fact, we are asked to find n, not prove that. Find n if n plus 3 factorial is 110 into n plus 1 factorial. Now we have seen that factorial of greater can be expressed in terms of factorial of smaller. Which is greater, n plus 3 or n plus 1? Obviously n plus 3. Let me explain. So factorial of greater is factorial of smaller, that is n plus 1 factorial. Go on adding 1 unless you get greater. So n plus 2, n plus 3. Okay. RHS as it is 110 into n plus 1 factorial. Can I cancel n plus 1 factorial? I can. Now many students, they solve this equation. That is not wrong, but that is not required. Why? Because n is a natural number. So can I say that n plus 2 and n plus 3 are consecutive natural numbers? Yes, they are. So it is sufficient to express right hand side also as product of two consecutive natural numbers. I repeat this, n is a natural number. So n plus 2 and n plus 3 are consecutive natural numbers. So express right hand side, that is 110, as product of two consecutive natural numbers. Do not write this as 11 into 10 because 10 comes before 11, right? So n plus 2 into n plus 3 is 10 into 11. Here I am going to write LHS. We express RHS also. We express RHS also as product of two consecutive natural numbers. Two consecutive natural numbers. Freedom. Two consecutive natural numbers. So n plus 2 is what? 10. So n equal to 8. Some students say that there is another value. N plus 3 is 11. So that gives n equal to 8 only. Okay. Right down. Question 6. Find n if, first part, 17 minus n factorial upon 14 minus n factorial equal to 5 factorial. Which one is greater? Obviously 17 minus n is greater. Factorial of greater can be expressed in terms of factorial of smaller. How? Factorial of smaller into, go on adding 1 unless you get greater. So 15 minus n, 16 minus n, 17 minus n. Okay. Now this gets cancelled. 14 minus n factorial. Note that n is a natural number. So this is product. This is product. LHS is product of three consecutive natural numbers. So express 5 factorial, that is 120, as product of three consecutive natural numbers. You may say 120 is 1 into 10 into 12. Absolutely right. But 1, 10, 12 are not consecutive, right? 5, 4, 3, rather 5, 4, 6. This product is 120. But 5, 4, 6 are not consecutive. 4, 5, 6 are consecutive. So 15 minus n is 4. So n is nothing but 11. Third one, n factorial upon 3 factorial into n minus 3 factorial is 2. Ratio is given. N factorial upon 5 factorial into n minus 5 factorial equal to 5 upon 3. Now a upon b upon c upon d is what? A upon b into d upon c. I have directly cancelled n factorial. So what remains is 5 factorial into n minus 5 factorial. This goes to numerator. upon what? 3 factorial into n minus 3 factorial. Now 5 factorial is 120. You may say 5 factorial is 3 factorial into 4 into 5. Absolutely. But so many factorials are there. So I directly put the value. Now, which is greater? You have to be very careful. N minus 3 is greater. Suppose n is 10. 10 minus 3, 7. 10 minus 5, 5. So 7 is greater than 5. Factorial of greater is factorial of smaller. Go on adding 1 unless you get greater. Equal to what? 5 by 3. Now, how to simplify this? This gets cancelled. Okay. Then I will directly write this. So n minus 4 into n minus 3 equal to what? 120 into 3 upon 6 into 5. So this is 3 into 4. I hope you are getting this. If not, cross multiply and then rearrange. In fact, for rearranging, first cross multiply. I have directly written this. Like LHS, I have expressed RHS also as product of two consecutive natural numbers. In exam, you have to write this. Otherwise, you will have to obtain quadratic equation, discard one value and so on. Because if you obtain quadratic equation, you get two values, n equal to 0, n equal to 7. But how can n be 0? In that case, factorial of negative number will be defined, which is not actually. Okay. But this is the simplest method. But here you have to mention that like LHS, we express RHS also as product of two consecutive natural numbers. That is why n minus 4 is 3. So n is 7. Now this is similar sum actually. Fifth one, 2n factorial. See, 2n should be put in bracket. Otherwise, it will mean 2 into n factorial. It is factorial of 2n upon 7 factorial into factorial of 2n minus 7 equal to n factorial upon 4 factorial into n minus 4 factorial. 24 is to 1. So a upon b upon c upon d is a upon b into d upon c. Now, next step is important. See, which is greater? 2n is greater. So factorial of greater is factorial of smaller, that is 2n minus 7 factorial. Go on adding 1 unless you get greater. So 2n minus 6, 2n minus 5, 2n minus 4, 2n minus 3, 2n minus 2, 2n minus 1, and finally 2n. Here which is greater? N is greater. So n factorial is n minus 4 factorial into n minus 3 into n minus 2 into n minus 1 into n. What about right hand side? 7 factorial is 4 factorial into 5 into 6 into 7. This 24 as it is. Okay. So see what gets cancelled. 2n minus 7 factorial gets cancelled. And here n minus 4 gets cancelled. So what remains is this. See, these many terms. Now can we simplify this further? Yes, we can. See the cursor. From 2n minus 2, 2 is taken common. From 2n minus 4, 2 is taken common. From 2n minus 6, 2 is taken common. So already 1, 2 is there. That is why you can see 2 raised to 4. Okay, this step is shown here. No problem. See, this is how you have to write detailed solution. So 2 into 2 into 2 into 2, that is 2 raised to 4. What remains? 2n minus 1, 2n minus 3, 2n minus 5. Okay. Why? Because n gets cancelled. N minus 1, n minus 2 and n minus 3. These terms get cancelled. So you get this. That is 2n minus 1 into 2n minus 3 into 2n minus 5 equal to, see, 9 into 7 into 5. Note that left hand side is product of 3 consecutive In fact, I will not say consecutive because 9 is the greatest, but if you consider from right to left, then product of 3 consecutive odd numbers. See, 2n minus 5 is definitely odd. The next odd is 2n minus 3. The next odd is 2n minus 1. That is why right hand side is also expressed as 5 into 7 into 9. So equate. You need not write all. You just say 2n minus 5 equal to 5. So 2n equal to 10. So n equal to 5. 7th, show that n factorial upon r factorial into n minus r factorial plus n factorial upon r minus 1 factorial into n minus r plus 1 factorial equal to n plus 1 factorial upon r factorial into n minus r plus 1 factorial. We'll be solving this sum in combination. So at present we begin with LHS. Now, which is greater, r factorial or r, rather r or r minus 1? R. So r factorial is r minus 1 factorial into r. This is quite logical. Factorial of any number is factorial of 1 less multiplied by that number. Which is greater, n minus r or n minus r plus 1? Obviously n minus r plus 1. Factorial of greater is factorial of smaller or factorial of 1 less multiplied by that number. What can be taken common? You may say we will find LCM. That is also correct. But here I have taken n factorial upon r minus 1 factorial into n minus r factorial common. So what remains in the bracket is 1 upon r plus 1 upon n minus r plus 1. How to add these two? Find LCM, which is r into n minus r plus 1 and so on. So see what you get. This is n factorial upon r minus 1 factorial into n minus r factorial, r n minus r plus 1, n minus r plus 1 plus r. So LCM r into n minus r plus 1, this is numerator. So n factorial into n plus 1 upon, see throughout product is there. So r minus 1 factorial into r and n minus r factorial into n minus r plus 1. Factorial of any number into immediately next number is factorial of next number. Take particular value. Suppose n is 10. 10 factorial into 11 is 11 factorial. Simple. Same logic here. Factorial of any number into immediately next number. Immediately next is important. Is factorial of next. Same thing here. In fact, you will notice that from this only we had written this. Okay. So this is right hand side. 9th one. Show that 2n factorial, that is factorial of 2n upon factorial of n equal to 2 raised to n into 2n minus 1, 2n minus 3 up to 1. Note that 1, 3, 5 up to 2n minus 1 is product of odd numbers. The first odd number is 1, then 3, then 5. 2n minus 1 is definitely an odd number. Okay. Now, numerator product of first 2n natural numbers, denominator as it is. Let me explain. Now I have made two groups. You will observe that in the first group I have included 2, 4, 6, 2n minus 4, 2n minus 2, 2n. That is, all these are even numbers. In the second bracket I have written odd numbers. 1 is odd, 3 is odd, 5 is odd. 2n minus 3 is definitely odd. The last is 2n minus 1. I mean, last odd is 2n minus 1. Okay. Denominator as it is. Now, from numerator, see, this is interesting. 2 can be written as 2 into 1. Okay. 4 can be written as 2 into 2. 6 can be written as what? 2 into 3. Then 2n minus 4 is 2 into n minus 2. Then 2 into n minus 1 into 2n. This is not at all difficult. Every even number is 2 times. 2 times something. Okay. Into this part as it is 1 into 3 into 5, 2n minus 3, 2n minus 1. Okay. Denominator as it is. Write down this. Now 2 into 2 into 2. How many times? Each of the n terms contains 2. So 2 raised to n. Then what remains is 1, 2, 3, 4 up to n. This as it is, denominator as it is. Now 1 into 2 into 3 up to n is n factorial, which gets cancelled with this n factorial. So what remains is this. The only thing is I have written this in reverse order. 2n minus 1, 2n minus 3 up to what? 5, 3, 1. That's it. 10th one, we are asked to simplify. First, second, third, these are simple ones. If you want, I'll tell you answers also. Answer for the first one is 2n plus 1 into 2n plus 2. For the second, n plus 3 upon n minus 2. And for the third, it is minus in bracket n plus 1 upon n into n minus 2 factorial. Okay. Fourth one, we are asked to simplify this. So n into in bracket n factorial plus n minus 1 factorial plus n square into n minus 1 factorial plus n plus 1 factorial. So n into, actually n is taken common. So just a minute. Okay, so n as it is. Now what is n factorial? Factorial of any number is factorial of smaller into that. So n factorial, I usually write n minus 1 factorial into n. Here they have written n into n minus 1 factorial. Plus n minus 1 factorial as it is. N square into n minus 1 factorial as it is. Now what is n plus 1 factorial? It is, see the cursor, factorial of greater is factorial of smaller, n minus 1 factorial. Go on adding 1 unless you get greater. So n plus 1. Now from all these, n minus 1 factorial can be taken common. So what remains is n into n plus 1, okay, plus n square plus n plus 1 into n, because I have taken n minus 1 factorial common. Now this is nothing but n minus 1 factorial into n square plus n square plus n square plus n. That is 3n square plus 2n. So n into n minus 1 factorial into 3n plus 2 factorial. Now factorial of any number into immediately next number is factorial of next number. So it is 3n plus 2 into n factorial. See, I'll give some time to go through the solution once again. But let me explain fifth also. N plus 2 upon n factorial minus 3n plus 1 upon n plus 1 factorial. Now, n plus 1 is greater than n. So it is n plus 1 factorial. It is n factorial into n plus 1. See, I think what I write is rather can be understood easily instead of this. Factorial of greater is factorial of 1 less into that number. Okay. What is taken common? 1 upon n factorial. What remains in bracket is n plus 2 minus 3n plus 1 upon n plus 1. LCM is n plus 1. Simplify. So what is numerator? Numerator is n square plus 1. So what is the final answer? It is n square plus 1 upon, what is n factorial into n plus 1? N plus 1 factorial. Okay. 10th one, sum number 7. 1 upon n factorial minus 3 upon n plus 1 factorial minus n square minus 4 upon n plus 2 factorial. Which is the smallest amongst n plus 1, n plus 2, n. So factorial of remaining must be expressed in terms of factorial of n. So what is n plus 1 factorial? Factorial of any number is factorial of 1 less into that. What is n plus 2 factorial? Factorial of any number is factorial of smaller. Go on adding 1 unless you get greater. Now 1 upon n factorial can be taken common. So 1 minus 3 upon n plus 1. What are the factors of n square minus 4? N minus 2, n plus 2. So n plus 2 gets cancelled. So what remains is n minus 2 upon n plus 1. Within bracket, LCM is n plus 1. Numerator, n plus 1 minus 3 minus n plus 2. So this is 0 upon non-zero equal to 0. Sum number 8, n square minus 9 upon n plus 3 factorial plus 6 upon n plus 2 factorial minus 1 upon n plus 1 factorial. Now n plus 1 is the smallest amongst these. Now factorial of greater can be expressed in terms of factorial of smaller. How? N plus 3 factorial is n plus 1 factorial into n plus 2 into n plus 3. What are the factors of n square minus 9? N minus 3, n plus 3. So n plus 3 gets cancelled. Here n plus 2 factorial is what? N plus 1 factorial into n plus 2. This is as it is. Take 1 upon n plus 1 factorial common. What remains is n minus 3 upon n plus 2 plus 6 upon n plus 2 minus 1. Within bracket, LCM is this. So what remains is 1 upon n plus 1 factorial into n plus 2 factorial of any number into immediately next number is factorial of next number. So what remains is 1 upon n plus 2 factorial. Now we start with permutations. Let us consider 3 points. I know that points are usually denoted by ABC, but I'm denoting points by 1, 2, 3. If I ask you how many distinct lines are possible, 1, 2, 3 are non-collinear points. So how many lines? Line 1, 2, line 2, 3, line 3, 1. Will you say that 3 more lines, line 2, 1, line 3, 2, line 1, 3 are possible? No, line 1, 2 is same as line 2, 1, right? So here out of 3 things, we have considered 2 at a time and number of ways equal to 3. But if I ask you to obtain or write 2-digit numbers by considering any 2 out of these 3, will you say that 1, 2, 2, 3 and 3, 1 only? No, because 1, 2 is different from 2, 1. 2, 3 is different from 3, 2. 3, 1 is different from 1, 3. What is the similarity between these two? In both, out of 3, 2 are taken into consideration. But in the first case, order is immaterial. Line 1, 2 is the same as line 2, 1. But here, order matters. Order is important. The order in which digits are written is very important. Otherwise, students securing 100 and students securing 001, are they on the same level? No, because here order is important. So if the order is important, it is a problem of permutation, and if order is immaterial, this is just selection, then it is called as combination. So I repeat, in case of permutation, order is important, and in case of combination, order is not important, order is immaterial, because this is just selection. Okay. Now we are interested in obtaining number of permutations of n things taken R at a time. This is how it is written. This is called as prefix. This is called as suffix. P stands for permutation. So this is permutation, that is an arrangement in a straight line. We are going to discuss one more permutation called as circular permutation. But initially, we are going to define permutation as what? It is arrangement of things in a straight line. So in all, there are n things or n objects. Out of these, r objects are to be arranged strictly in a straight line. So clearly 0 less than or equal to r, less than or equal to n. Now you may say, how can r be 0? Means nothing is arranged. Okay. So r has to be less than n. In some cases, it is equal to n. For example, there are 10 students and all of them are to be arranged in a straight line. So it is possible, but usually r is less than n. Now we are going to prove the formula for NPR. NPR is n factorial upon n minus r factorial. Before considering general case, we will consider particular case. Suppose we want to find 6p3. What do you mean by 6p3? 6p3 means arrangement of 6 things taken 3 at a time. If there are 6 things, there will be 6 places, because it is possible that all 6 are to be arranged. Okay. So 6 things are there in all. So 6 places. But we have to consider only 3 at a time. Now out of these 3, first can be arranged in how many ways? 6 ways. Why? Because 6 places are available. So the first thing which we are going to arrange has wide range of, rather 6 choices are there. So that thing can be arranged in 6 ways. Now second thing cannot be arranged in 6 ways because one place is already occupied. So second can be arranged in how many ways? 5 ways. And third can be arranged in how many ways? 4 ways. See, there are 6 objects. Okay. So first object, 6 choices. Suppose first object is occupied, rather has occupied this particular place. So how many are left? 5. That is why I am saying second can be arranged in 5 ways. Suppose second occupies this place. So third has only 4 options available. So third can be arranged in how many ways? 6, rather 4 ways. So by fundamental principle, total number of arrangements is this. But we have discussed this, how to express this in terms of factorial. 6 into 5 into 4. I multiply numerator and therefore denominator by what? 3 into 2 into 1. Note that numerator is product of first 6 natural numbers. It is 6 factorial. What about denominator? It is product of 3 natural numbers, 3 factorial. Now let us verify the formula. NPR, see, this is not the proof. I'm going to explain the proof, don't worry. 6p3. So n is 6, r is 3. As per this formula, 6 factorial upon 6 minus 3, 3 factorial. Yes. Okay. So let us obtain this result. Our aim is to arrange n things taken r at a time. So the objects to be arranged, that number is r. First object can be arranged in how many ways? N ways. Because for n objects, n places are there. First object has wide choice. It can occupy any of the n places. Second object, n minus 1 ways. Third object, n minus 2 ways. So last object in how many ways? N minus r plus 1 ways. I'll explain. See, first object n ways. Second, n minus 1. Third, n minus 2. So r from n, you have to subtract r minus 1. So how many ways? N minus r plus 1 ways. I repeat this. there are n objects, but we have to arrange only r out of them. First object can be arranged in n ways. Second, n minus 1. So for second, 1 is to be subtracted from n. For third, n minus 2. So for rth, subtract r minus 1 from n. So n minus r plus 1 ways. This means first object in n ways, second n minus 1, and last, that is rth object, in these many ways. So by fundamental principle, total number of arrangements is what? N into n minus 1 into n minus 2 up to this. But we want to express this in terms of factorial. See what I'm doing? I multiply this numerator by what? See, 1 into 2 into 3 up to n minus r. So I have to multiply denominator also by that. N minus r minus 1 till 3 to 1. Note that numerator is 1 into 2 into 3 up to n. That is product of first n natural numbers. That is n factorial. What about denominator? 1 into 2 into 3 up to n minus r, which is product of first n minus r natural numbers. So it is n factorial upon n minus r factorial. Is that clear? So this is the formula. Tomorrow I'll explain the proof once again. So even if you haven't understood it, no problem. Now, what is NPN from this? NPN as per formula is n factorial upon n minus n, because r is also n, 0 factorial. But 0 factorial is 1. So n factorial. Okay. Now this is an interesting part. What is NPN? NPN is arrangement of n objects taken all at a time. This number NPN can be obtained without using this formula. How? See, n objects are to be arranged. First object can be arranged in n ways. Second, n minus 1. Up to last, 1 way. So by fundamental principle, n objects can be arranged in how many ways? 1. I haven't written in 2 here, but it is 2. So 1 into 2 into 3 up to what? N, which is nothing but n factorial. So permutations, that is arrangements of n things taken all at a time, is n factorial. But as per formula, it is n factorial upon 0 factorial. Now, even if we change the method, or if we use different logic, answer should not be different. So for these two values to be equal, 0 factorial has to be 1. So this is how we can explain the logic behind 0 factorial equal to 1. Okay. So that's it for today.